Topic for this session is called Java Web Frameworks. And before I will go into Java itself, I will quickly review also what web is. For those of you who may be less educated and less skilled in web development itself. So first thing is this difference between internet and web. And sometimes you may say that these are the same, but actually not, because if we write it as a class diagram, web is some part of internet, or we can say that web depends on internet. And if we are looking from protocol perspective, internet is data exchange using internet protocol, but web is data exchange using HTTP protocol, with or without S, so S adds here just an encryption. And this is lower level than internet protocol. If we look on some previous presentations about network in general, this page, HTTP protocol is application layer protocol. This is how data are described and exchange is described between one application and another application. But internet protocol is about this layer, how network works, how you transport data from place to place, and how you deal with TCP/IP sessions or connections in jargon to reliably send data from one place to another. So that means you use TCP/IP connections between web clients and web servers, and it is centralized solution. You have servers which serve something, and you have web clients which use these servers. You can call usually these browsers. And if you look on Lifeline here, so these browsers create TCP/IP connection here. They do this handshake part. And then when this handshake is done, starting with this part, they can do business here. That's how that looks in this sequence diagram. And then this business may be complicated. There may be many connections, many data transmissions between client and server and everything else. Then, particularly about HTTP protocol. So web is based on HTTP protocol, which is this application layer protocol, or describes how one application interacts with another application, like web browser with web server. An important part for this protocol is unified resource locators. Unified resource locators are subset of unified resource identifiers, or vice versa. Unified resource identifier is part of URL. And what we call as a jargon address, it is this unified resource identifier. So when we open here, but here inside this. So this part, everything together is URL, which includes also transport protocol and something else, maybe somewhere here. But unified resource identifier or address in jargon is that part. So in URL you have transport protocol also given, and you know, for example, that for Git repositories, etc., it may also have something like user at host at port, etc. So it, I think, something like this. So you add more information about this resource location before that, but then you have this particular address. And how these addresses are managed? This part is domain name system. And this part is virtual folder and files. So here, of course, you should already know that for some historical accident, domain name system do not follow rules for proper place of important parts. Most important part is on the right side, less important part on the left side. For example, test.odo.lv is some subset of DNS entry for odo.lv. But starting here from this slash, this again is properly ordered. Parent things are on left side, less parent things are on right side. Depending on how your particular web server works, you may or may not say explicitly that this is actually a folder. If you add slash at the end, you say explicitly it is folder. If you do not add, it may be either folder or file inside this virtual folder. And if you browse something like statically built web pages, like JavaDots for Java 11, then what you see here in URL, these are actually folder inside folder inside folder, and then particular file inside this folder. So then what you see in URL here, you see that somewhere inside your server there is also similar data structure in your file system of your folder. And then you may add two kind of directives into this URL, and question mark after address and hash. If you add question mark after address, then it is additional instruction like parameters sent to the server. And here is one Easter egg built into this website, that if you know what parameters you can pass to the home page, it shows here welcome to particular user. And if you have many parameters, you have in structure key value and key value and key value. And if these keys and values are not Latin characters but non-Latin characters, you need to encode them somehow, and leading de facto standard for encoding is UTF-8, and in this particular case this UTF-8 encoding is then escaped with so-called URI escaping characters. or URL. And if you encode it, this becomes such kind of sequence. Particularly for domain name here, until recently only Latin letters were allowed, but now with more modern web servers and standards, there's also standard how can you use non-Latin letters also for domain name system, and it uses different encoding mechanism. So on here you see how it's escaped in Latin letters. Unfortunately something is not working here anymore. That what is here as a non-Latin letters is actually escaped in a way that first there are all Latin letters and then it says in which places you need to replace it with something else. And how this standard is called, I do not know. But this is not widely used in difference with Punycode, that's how it's called. So, and then there may be other parameters sent back to the browser. For example, if we open some web page and when server produces some HTML code here, it may also add instructions at the end of this address, and these are instructions to the client. And what client usually does with these instructions, this key value, key value, key value after hash mark is usually handled by different kind of JavaScript frameworks. So if you need some kind of dynamic execution of code, maybe update of your produced HTML here or whatever, then everything after hash mark is additional instruction to the client, to the browser. And it is very widely used for example, when you do redirection. And redirection means that client opens one particular URL and server sends instruction to the browser in different ways. Please open this different address or URL to be more precise. And then in this different address there may be these additional instructions given, which are then handled by web client. And in general, what is good style is that, of course, DNS names are already globally unique, but in general, except some modern web frameworks, good style is that for each unique resource in the web, there should be unique URL to get this resource. And of course, this is not always the case, because if you open some like web portals with news, etc., then of course you will get completely different content using the same URL. So, but if you look on particular article in these portals, etc., then it's still good style that each unique resource has unique URL to reach it. So that's about addresses. And then how this interaction works. Interaction is served like request response, and there may be different kind of requests. And you should know at least get and post kind of requests, but there are also put, delete, head and many other. And how does it look like? If we use this uncut command, which you should already know from this networking example, then we can emulate these requests manually by ourselves using this netcut command, and get looks something like this. You say first that it is get request, and then you say show me content of root folder, and I'm using old school HTTP 1.0 protocol, and I got following response back. Something goes wrong. Where should it be? Let's use different. Still bad request. What is happening if it's timed? Netcut is eating up something. Okay, so use it with telnet, not the netcut. So I say it is get request, show me content of root folder. I'm using HTTP version 1.0. And here you should not mix two different important protocols. One is HTTP and another is HTML. For hypertext markup language, currently we are using mostly 1.x, 2.x protocols for transport protocol, which means it describes this interaction, how data are sent between client and server. But for hypertext markup language, which describes what content is sent back here as a content from server, is 4.x or 5. So do not mix them up. These are two different things. And so here I'm using very simple basic protocol to do this. Here I got content of localhost. And here, for this interaction, we talked about this in this networking exercise, how to say that you are finished sending your data. It is empty line send, or two line breaks in sequence to the server. And we got following response back, which says forbidden. So here are so-called response headers. You can also do request headers, and request header is just additional textual information, key, value, key, value, which may say more things about your client. And similarly, server responds first with status, number, description, and it uses HTTP 1.1, not 1.0. And here is some response headers. Key, value, It says it's Apache server running on Ubuntu. Content length is following number of bytes. Connection is closed. After that, text encoding is following. And what does it say here? And here it responds with HTML. And HTML is this markup language where you write simple plain text documents. And if you want to make it not plain text document but structured text document, you mark it with these marks. Smaller than name of tag, larger than content of the tag. Inside it you may have also key equals value, and then closing tag. So everything what is not simple plain text, how to be described with these additional tags here. And what this server says, you do not have permission to access this resource because server do not respond on port 80 besides this error message. So what do we need to do? We need to use HTTPS protocol, which is a little bit more complicated because we need to do, we can show here how this exchange looks on Wireshark or Wireshark. How do we filter out for address? This way. Okay. And here is this communication recorded, so we can ignore SSH packets, but for HTTP, so following packet was sent to the server from my computer, and you see here information about Ethernet frame, information about Internet Protocol, source address, destination address, source port number, destination port number, sequence of the packet, acknowledged packet, length of packet, etc. And here is actual payload, actual application layer protocol, get blah blah blah, line break in DOS format, not in Unix format, line break end of request. And here is some other things recorded, but here is response from the server. Of course I received Ethernet frame, but inside data of this Ethernet frame is data about Internet Protocol packet, source address, destination source port, destination port, sequence number of this packet, acknowledgement of this packet, length of the packet, and actual content here. And that's what I saw here on this telnet. Then similarly I can do it properly on HTTPS. Only difference is that I have to establish encrypted communication channel before. And to do this manually, one of the things I can do, I can use OpenSSL client. I needed to start recording already. And then I can send some data here. So here I see output from this OpenSSL client, how this communication worked. So to open port on this port, first I need to receive public key of the server, and encryption here is done using public key infrastructure. So it works in following way, that the server has registered public key in its certificate, what you can see in web browser. In this additional information here. And it also has pair of private key, so it sends this public key to client, and client may review is this belongs actually to this company, belongs to this DNS name, etc. Then it creates random number, encrypts this random number with public key of the server, sends to the server decrypts this random number with its private key, and then after that they encrypt everything with symmetric key using this random number given by the web browser, because that works much faster. And if you debug it here, so you see here information about this certificate, then this public key given to it, and then when I send this, where is received thing, I don't see one. But, and here somewhere where we start HTTPS protocol, we see this handshake somewhere created here. And unfortunately I see some additional transmission happening here, but it is regarding to this HTTPS protocol, which you can see here when it started. So transport layer security version 1.2 blah blah blah, and then different kind of encrypted data are sent. And then you can also use different kind of requests, like post request. Then you say it's post request, still protocol 1.0. You definitely have to add a request header, timeout. So you definitely have to let's try it again. And we got following response, but this is not HTML retrieved here. Okay, so we will do it in following way. We will open it in web browser, because web browser knows how to send encrypted data to the server. So every web browser has inspect feature built in for debugging purposes. Usually it's F11, something like this. But I usually open in Firefox, I open it with right click. And so then we can go to network and record this request again. And what do we see here? Here we see recorded request response, request response, request response between this client and server, and you see that the interaction was actually quite long. Why? Because when server sends back this HTML content to the browser interprets these instructions and does something else. And what may be given here from this server to the browser So one thing I already mentioned, HTML as a hypertext markup language, and that is initially, and then this HTML is interpreted, and if this HTML says download also mentioned resources from here, then another requests are created to download other resources. What these may be? These may be images, video, audio or sound, cascaded style sheets and JavaScript files. And then all these are requested from the server when this HTML is interpreted, and all these additional resources are also provided to the client. And then CSS is interpreted, JavaScript is interpreted. If JavaScript says please download this as well, then it downloads something more here. And if JavaScript says please refresh this page or do redirect and open this page again for 1 minute or whatever, you will see that your page is refreshed automatically, etc. And so that would be classical old school HTTP using HTML. Some of more recent web frameworks do it differently. If you have client and you have server, client sends, of course it does it handshake if it needs to do HTTPS protocol, but when it says something like get root folder, HTTP blah blah blah, instead of providing HTML, it immediately sends JavaScript. And then the JavaScript is interpreted, and it may happen that the JavaScript requires to open other resources where instead of HTML etc. some structured data are sent, usually in JSON format. And then the JSON format is handled with the JavaScript applications downloaded from web server to the web browser, and HTML is actually finally created dynamically out of these data files. So then it and different kind of social networks work in such way. For example, if you open Facebook.com, let's inspect this as well. I need to open network. And let's stop it. And redo it again. So what we initially see here, that bunch of style sheet is downloaded and bunch of JavaScripts. And then if you look on HTML file, there is almost no HTML file, something initially here. And what is good about such applications, you can create more responsive, more user-friendly applications, because many of things may happen here inside the browser, not inside the server. So you can do less interaction with the server, because every time you interact with server you need to send some data over the world and receive this data over the world. What is not so bad is that these do not follow rules of web, because Facebook and similarly LinkedIn or whatever, they do not have unique URLs for unique resources, and many of them are actually closed. So it is not normal web anymore, because it do not allow indexing, it do not allow searching using indexing engines. Of course, Google can index and search them, because Google is a big company and Facebook is a big company, So big guys here can make the deal by themselves and it works, but for everybody else it is very closed golden cage or walled garden. And then you can do different kind of requests. Put means upload data to server, delete means delete this data from server, head means just look at some metadata about this, etc. And then I already told you, response is first is status, which says is it okay or not okay. Here you can see it in browser. Then there are these response headers, what server tells about itself. And then there is actual content, HTML, cascading style sheets, JavaScript and binary files like GIF, PNG, JPG, blah blah blah. And initially there was no state remembered or anything remembered on server side. Every time you had to remind something to the server, you had to send values of so-called cookies. And value of cookies are not here, here. So server also sends instruction to store some cookies on your web browser. Initially these cookies were stored as small files, key value, key value, key value. But more recently there are two kinds of cookies, session cookies and permanent cookies. For session cookies, you remember them only inside virtual memory. And for permanent cookies, you actually store them inside file. And for example, if I log in to the system, it also adds cookies for my browser to remember, and these are somehow hashed with some salting, etc. But every time when I open some resource and I send value, username, this value, validation, this value, and something else, then web browser knows that I'm actually authenticated user, I'm not anonymous user anymore, so I can edit some resources, etc. But problem is that for more complicated systems, this number of cookies which are sent, and for example here, when you look on network, these cookies are sent in various request headers. Let's record them again. So you have to send these values of cookies for each particular request. List of key value for cookies for this resource, JavaScript, for that resource. And of course, in more complicated systems, it becomes quite inefficient because for each of these unique URLs, you have to send the same information to remind server that that's me, I'm authenticated user. And therefore, for later implementations of web, they implemented other thing called sessions. So initially, for old school HTML, you remembered state in cookies on client side. And for each particular request, you send all values of cookies for each particular request. And if you send 100 requests, you send value of cookies 100 times. But if server also supports sessions, then it starts remembering things, and for each particular connection created here or session, formally it's called session, but in jargon it's connection. Server can remember key value, different kind of session variables for each particular connection. And that means only things that you can need to send here is your session ID. And then everything else may be stored on the server. So good thing is you don't need to send so much data to the server. Bad thing is that your server becomes more complicated and it's not scalable, because if you have a farm of servers and one of these servers has this session variables and not for this session ID and another server doesn't have, so when load balancing happens and you are going to different server, then your session is lost, you are anonymous user again. So problem for session is good that it's more efficient, so it's usually used for most of different web applications. For large scale solutions it is a little bit complicated because it is not scalable. You have to share all these sessions between your many servers if you have load balancing servers responding to the same IP address. And what are Java solutions here? There is no web server in standard Java. Standard Java supports only TCP/IP networks. And therefore you usually use different kind of external libraries and solutions like HTTP server from Sun Microsystems, or you can use HTTP servlets if you like Java server pages, etc. So almost everything, particularly for web, you use additional Java frameworks and libraries which are not part of standard Java itself. So you need to add them as dependencies in your project, you import them, and then you use them in different ways. And what are things for you to remember? First, what are the most popular ones, particularly in Java, like Spring Boot, which we will be used for practical exercise, also Jersey, Dropwizard and Spark, enterprise framework like Spring and Struts. Actually, Spring Boot today also may be considered enterprise framework. It is stable and robust enough to be used in enterprise. And there are some other frameworks which are running in Java Virtual Machine but are written in different programming language, like Google Play, written in Scala programming language, and Groovy Grails, written in Groovy programming language. And simple web server, like interpreting PHP scripts, work in such way that usually you have a relational database to store your data. Then you have plugin to interpret PHP programming language, and then client connects to the server, requests particular HTML or PHP files for it. PHP files are interpreted first, and then produced content is sent to the browser. And that's how it works, for example, when you have Apache server or Nginx server with PHP. For Java, usually you have this dedicated application server, which allows you to manage Java web applications inside it. Create new, delete old, restart it, etc., etc. And this application server leading families are Jetty as a single jar file for small applications, and Tomcat as an enterprise server for large Java applications. And then you run these Java applications inside this application server. Still you may have relational database, and usually this application server is not exposed to internet directly, but it's listening only in localhost interface, and then you can expose it to the internet using web server as a proxy server, starpnieks, between internet and your application server. Why it's done in such way? Because here in this web server you may have other applications written in PHP as well, and something else. So usually you do not expose just application server to the internet. If only web application you have is Java application written in Java, you may expose your application server to the internet, but in large enterprise systems, typical example is that application server listens on localhost interface, and then there is additional modules for web server which makes connection between your internet address of your server and localhost address of this application server. And so web application servers allows you to manage all these Java applications, and you need to remember that Java is compiled language. That means when you create something like blah blah blah.java, it is actually compiled to blah blah blah.class. And that's what is actually executed in web application server. But for web application server, it can do this compilation on demand. So if you say something like please execute this blah 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 class, and there is not such class compiled, web application searches where this source code is, compiles it, loads it, and executes some part of it. And so it allows you to manage, for example, update specific classes, put your source code to server, it will compile it and create package out of it, and all these things which are needed because Java is compiled programming language. And how do you write these Java web applications? Particularly to handle requests for the web, you usually write not full Java applications, but so-called servlets. And we will talk about applets tomorrow, but servlet is small Java file, like, I do not know, do this.java. And it doesn't have public static void main method there, but it has something like do this method inside it. And here is somebody. So that would be one typical applet. And then your web application server and your web framework you are using will load, compile this class, will call this do thing method depending on what kind of URL you pass to the server. For example, if you say that something like do, opening address do this should call this method, this framework will call this method and execute it. And these servlets may be two different types. There may be just TCP/IP servlets, which may be used, for example, when you need to implement something completely new using just TCP/IP protocol. But in most of cases you have so-called HTTP servlets or web servlets. And for these servlets, when you implement them, you have to implement like different kind to handle GET, POST and other requests. And if you will not implement them, of course, these particular requests will not be handled and you will get some kind of error from the server. And then you do implement them, and usually how do you do all these methods return some kind of text, and this text is HTML. If it's HTML, you can return something else if you like, and then you can pass parameters to it with as arguments. You can do many other things, what I will go into details for practical exercise. And then I will just mention this. This technology is now considered old, but JSP was very like writing applications similarly to PHP programming language. And what is PHP and JSP? Mostly you write produced HTML or XML or CSS or whatever content for your application, because in many cases for your application many parts are fixed, they are not changing during time, so it's very nice if you can write everything just as a produced HTML. And then you have these injections of Java code. In PHP that would be smaller than question mark, in Java it's smaller than %, and then you execute and create some dynamic part of this HTML through the Java code. So this approach was very popular around year 2000 and later, 2010, as an alternative and better structured code than writing applications in PHP. And when I worked as a build master and tester, usually I had some templates for these GSP pages to create and test, for example, that environment is working correctly. But when more modern Java template engines appeared as a frameworks and libraries, then GSP was considered not so user-friendly and dynamic, and so I will not be surprised if you will see GSP used in some older projects like in Accenture or other companies, but usually you do not start writing new web applications using GSP, you start using some other template engines and template frameworks like Timeleaf or other things which are dynamic of code is based on servlets, but static part is similar, principle is similar to GSP, but there are many differences. Mostly it is Java annotation based injections. So if you are curious, you can, for example, look for particularly, for example, this web framework for Java. So similarly, you write your template for your HTML as a HTML, but then you have different kind of syntax elements how you can put dynamic part of your code for your objects, some global variables, constants, etc. And now about Spring Framework. So Spring Framework was developed as an open source framework for large Java web applications, and it introduced quite a lot of different concepts and approaches, and one of these important approaches is POJO and dependency injection, and model view controller approach. So model view controller approach, we will talk in details also about Java applications, but idea is that all applications, if they are used by user, have three important parts. Model, which describes your business model or structured data. View, which describes what user may see on screen inside browser or Java application or mobile application or whatever. And controller, which connects these things together. Particularly for web applications, you also may have this controller like dispatcher servlet, which decides which kind of URL should go to which kind of calling method inside Java. So anytime you say something like different address for your host here, slash blah blah blah, slash blah blah blah, maybe question mark blah blah blah. So this controller or dispatcher decides which method in which Java class should be called. In general, this is part of controller, but you can also distinguish it as a separate entity. And then you may have this fixed part of your templates like GSP or Timeleaf for your view, Then you may inject some dynamic part of this code there, and then you respond it back. And also, I think what they introduced these POJOs, and that was very important around year 2000 and later, when different kind of new web applications were developed in top of old applications. So when I talked to you about database, for example, you may have some accounting database here, and in old school approach, initially it could be working like this, that you had different clients, each of them has this database engine like Microsoft Access or FoxPro, and all this business logic was implemented in this programming language for this particular database, and they just send data to the database server to update actual just data. Then later dedicated database server was introduced, and instead of accessing data files and folders directly, they used SQL and databack. And then web happened and internet happened, and the idea was that problem here is that you need to install all these accounting systems on all your computers, and that's not nice, because greatest thing about web is that you have already installed browser, and everything which is unique for a particular application can be downloaded from the server. And so what they introduced here was they removed that part of these FAT clients. There was only one FAT client running on the server side, and web interface was added here as a front end of this business logic. So these were not, business logic was not running in client side, but was still running in server side. And to do this, very important part is how easy it is to introduce web interface for this existing business logic. And it's very easy if you can use your plain old Java objects as your business logic part, and you just add web interface for these plain old Java objects, that this particular POJO can be reached with this URL, this particular POJO can be reached and handled with this URL. So many of enterprise applications, when they were developed as web applications, they still used the same business logic. They do not rewrite everything from scratch, because if you rewrite everything from scratch, probabilities that you will fail is very, very high. But they added only this communication part, that for one particular web address, this particular method and thing would be executed in this existing business logic. And so if your web framework allows to use this plain old Java object, then refactoring existing code is much easier, because you mostly don't need to change anything in your business logic. You just need to add another interface, like web interface, on top of existing business logic. And particularly IBM introduced a little bit different framework, which they call JavaBeans. And JavaBean is a plain old Java object, which is, so what is precise definition of POJO? It is any ordinary Java object, not bound to any specific restriction, but it cannot extend any other class except implicit object, cannot implement interfaces, cannot use advanced features like annotations. So our student and our teacher objects are POJOs. This belongs to these criteria very precisely. Particularly IBM introduced a little bit different thing, like JavaBeans, which is POJO, which is serializable. So if you strict meaning of POJO, Java-Bean cannot be POJO because it implements serializable interface. But implementing serializable interface is not big sin, because only thing you do, you allow it for this object to be converted into stream of bytes. And if you do this, IBM, for their many applications, they implemented these web applications a little bit differently. As I told you, for these modern frameworks, that usually you do not send HTML from the server, but something else, like JavaScript. And then just serialize data like JSON. And then HTML, which you sooner or later or eventually see on screen, is produced on your browser at your end. And IBM used similar approach for their enterprise solutions. So instead of sending HTML here from this web part from web server, they send some partial HTML, but actual data were sent as a serialized objects. So JSON is text-oriented, you see everything as a nice readable thing. Serializable objects, of course, are binary data. And then you send this serialized object or Java-Bean to the client side. And then, for example, if it's collection of your customers, you go through this collection of customers and create HTML table on client side dynamically using, let's say, JavaScript. And it is quite efficient because HTML is quite verbose language. If you can send binary data here and you convert them to nice HTML on client side, it of course works much better. And depending on what kind of enterprise project you may be working in Accenture, it may happen that your colleagues talk quite a lot either about POJOs or about Java-Beans. So Java-Beans is mostly used by large companies like IBM, maybe Oracle, etc. But POJOs are quite widely used also for smaller scale projects. And then Spring Framework allows you to remember data on server side about particular session or connection in jargon. And there are different levels of these things what server remembers. First, it is a global session. This belongs to all server settings, like server remembers some general things about itself, about its configuration. So global session belongs to or can be used by any user connected to the system. Then for each particular user which creates each particular session or connection to the server, they remember some session level variables, key value about this particular session. And then there is request types and response values, which is for each particular request, each particular response. So remember, inside one TCP/IP connection, you can send several requests. So here I still have the same session on with my server, but I have sent 43 requests and got 43 responses. And so this means that in general you don't need to use any cookies at all. Only thing you need to remember is JSessionID cookie. But for practical purposes, because nothing is black and white, usually for different kind of validations, like for XWiki content management system, which is enterprise wiki written in Java, they also see how password as some hash for it and username and some validation key, etc. So not only this thing is sent and remembered to the server. And then they also introduced a design approach called inversion of control. Inversion of control is also quite important for web because we are using frameworks. In classical approach, you have public static void main method, which calls all other methods. Method 1, which calls method 2, which calls method 3, blah blah blah. So direction of calls starts from here, and then you go deeper and deeper and deeper, and then you go back. So that would be standard control. But when you start implementing your, let's say, servlets, you don't see it. You just implement like do get method, and it is called from outside, which you do not control. And it may happen even in opposite ways, that you call something else from this internal method, but to do this in opposite direction, when you go deeper and deeper and deeper in these structures, you automatically remember all things about your environment, like what your data structures were, etc. To call it in opposite direction from some internal method back to something else, this environment becomes very important. And so therefore you always need to rely on this session, request, response, because that is provided to you by server to know how exactly you do. And so in this inverse of control, you do not start with main general method and go deeper, 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 but you do in opposite direction. You start with some deep method like do get, and then with that you can call something more general inside your web framework. So that's what it is in general. And so, for example, here this item would be this like session variable or request variable, which you need to how to know to call something else from your internal method. If you are curious, you can go in details about this by yourself. And now about Spring Boot. So Spring Boot is quite recent framework, and it was developed on top of Spring Framework through frustration of using of Spring Framework. I have not developed any Java application in Spring Framework myself. I have tested it. And problem with original Spring Framework, which you still can use, is following, that it's quite hard to use because everything is configurable and everything has to be configured. And one of idea for original Spring Framework was that writing some values inside your Java code is bad, because every time you change something in Java, you need to recompile. And recompilation, of course, takes time, maybe error prone, etc. So instead, in this Java, you do read external parameters from config files, and for Spring Framework, these are XML files. And you can change these XML files without recompilation of your class, and that is considered good. Problem is that for original Spring Framework, you have dozens or hundreds of these XML files. Everything has to be configured in XML file. If you want to say for this particular web request, you need to call this particular class and method, you have to say it in XML file. If you want to say that this particular class is connected with this particular database object in relational database, you have to say it in XML file. And when I was testing these applications and look at our shoulder of my colleagues, I invented saying that if you are Java developer, but mostly you are writing XML files, then probability is very high that you are developing Java web application using Spring Framework. And so Spring Boot was invented in the following way, that if you accept defaults, no configuration. It's something like Maven projects, and this approach is called convention over configuration. Everything what can be set as some default value in Spring Boot framework is set as default value, and you need to configure it explicitly only if you are not happy with default configuration. And then they decided, okay, we got tired of writing XML files, we will go back to modifying Java files again, but other thing what they introduced is annotations. Because annotations is very expressive way how you can do different things. So Spring Boot is still using Spring libraries and Spring framework, but on top of that it allows you to pre-configure your project quite easily, and instead of creating many XML files, it allows you to add few annotations in your Java code and you are done. And then some newer. So web is always developing, and it of course becomes more and more complicated because bigger and bigger companies are using web for their needs, and of course needs for big companies are always complicated. So if you look on history, and I am old enough to see a little bit of history, so you started with, so here is your client, here is your server. Initially server didn't have no memory, and you had cookies on client side. So that was first level of remembering things and dealing with complexities. Second thing was too many cookies, and they introduced sessions on server side. Then problem, too many, let's say, session variables, which has all these problems about scalability, because if you do not have a relevant session variable on server side in its memory, then you don't know anything about this client. So this means this client is lost and it needs to be reconnecting, and if he or she was in between of several activities to go next to order some request in the web store or whatever, he or she becomes frustrated. So how can we do better? Third level here is this HTOS approach. First was actually HTOS, RESTful is something different. So this actually means you still remember things on the client side, but you do not use cookies. You add everything in URL in general, because URL is shorter, and for URL you can need to remind about these things only in these URLs where you need. And general this means that you have in URL, say, your resource which you are dealing with, operation, and everything else, like if it's unique resource, resource ID, including resource, etc. So you say everything what you have and what you need in URL instead of cookies, and if you don't need to say it, you make URL shorter. And so that has things that server don't need to remember anything again, so scalability is good. Everything is reminded to the server by client, but this reminding process is much more efficient because you don't need to send too many cookies. And particularly somewhere in between for this HTOS approach to be working, 2.5 was REST. And REST in general says everything is URL. That means if you need to get something unique, you need to generate unique URL. And if it's GET request, then everything is given into this URL, including parameters for server, maybe parameters for client as well. If it is POST request, you may also add some request headers for it as a key value combination in this test. But this is very important feature, because if you have to work with some system which follows this REST approach, and REST means representational state transfer, and this means stateless. State is not remembered. State is remembered in your URL, all resources have unique URLs, and all CRUD operations are set into URLs. So before that, they designed it that everything what you need to do with your web application should have unique URL, and if it has, then you also follow this HATEOS principle. I have no idea how it is designed. And if everything is URL, you may go a step forward. For example, you probably, if you had some experience creating some web application, not just static web page, you know that you need to create some template with buttons like CRUD operations for this particular resource. Like here I have some content management system, and I need to create HTML, for example, to edit it, to copy, move, delete, blah blah blah. So usually you end up, if you are old school guy, you use GSP or like Timeleaf framework, you create this static part of this HTML in your template. And it is quite a lot of work to do, because for every resource you are allowed to do this create, read, update, delete operations. You have to generate and create this template for HTML. But with this hypermedia of state transport, whatever, if you follow this REST approach and every operation for every object has unique URL or addressing jargon, what you can do is that you only describe data structure, and then these CRUD operations for data structure can be generated by web framework. If you know that your data structure is like customer 1, 2, 3, whatever, and then item, and you know that to add new item here is add, to delete current item here is your address del, etc. You can generate everything here automatically. And for example, Ruby Rails and Groovy Rails frameworks does this. You describe only data structures, and these CRUD operations for these data structures are described as something like hyperlinks. So you have not so nicely looking hyperlink to add things, to delete things, etc. But then you add only CSS as custom style shield to this, and you can change these hyperlinks as nice looking buttons like create, read, update, delete, and you are done. And then you don't need to spend much of time to describe and make interface for these CRUD operations. You describe only your data structures, you describe how these data structures will be reached through these URLs, and everything for this management can be generated by your web framework, and you just need to add style for it if you like. And that's how the most modern web applications can be created. For example, that you only describe your data structures, but then framework injects or add code automatically for these things to allow these CRUD operations to do automatically for each of these data structures. And we will talk about this later if you will decide to do web application for your teamwork, because everything else is actually already prepared for your individual exercises. So that's in short as a crash course for web development, including some of these recent innovations and complexities in the web. Do you have any questions or comments on this?